Hey guys, it's Mr. Donzi. Wanted to start making some videos for you guys to get the information to you that we would have been covering had we been in class after this break. So we're going to start with Chapter 8, Adding and Subtracting Polynomials. First off, what is a polynomial? There's different types of polynomials. We're going to start with the one that we're most common, or the one that's the most common, the one we've been working with, which are monomials. The prefix mono, meaning one, means that there's only one term. So we've got 5, a constant, that's an example of a monomial. 6x is an example of a monomial. And even if there's several numbers and variables in there, as long as it's all together as a product with multiplication, it's still considered a monomial. Now, a polynomial, the prefix poly, that means it's a sum and or a difference of a bunch of monomials. So all those monomials that I just had up there, if I put additions and subtractions between them, it ends up turning into a polynomial. Now there are different types of polynomials. And that first one is a binomial. Now the prefix bi, if you think of a bicycle has 2 wheels. A binomial means it's got 2 terms. So an example here would be 2x squared plus 7. 2x squared is a term, and 7 is a term. 5rx plus 7tuv is an example of a binomial because there's that one addition in between there that puts 2 terms together. So that's two examples there of binomials. Another example, a trinomial. The prefix tri means 3. So as you can guess, that I'm going to have 3 terms in there. So x cubed minus 10x plus 1 is an example of a trinomial because each of those 3 pieces are considered terms. Now you might have polynomials that pop up that look like it has 4 terms, so it might have a name for it, but you have to be aware that there might be like terms inside of it. So the 4x and the x that's in the middle, those are considered like terms, so I have to combine them first to have a simplified polynomial of 6x cubed plus 5x plus 3. Now I have 3 terms, so this is still a trinomial. If there are ever any more than 3 terms, we're just going to refer to it as a polynomial because it's got many terms in it. The only 3 that we have specific names for are monomial, binomial, and trinomial. Lots of definitions here. Next thing we're going to talk about is the degree of a polynomial. The degree of a monomial is the sum of the exponents of all of the variables. If there are no variables in the problem, then the degree is just the number 0. Because there are no variables, I have 0 as a degree. So here's one of the monomials that I gave you earlier on in the lesson. If you look at the exponents of the variables, x has a 1, y has a 2, z has a 3. I'm simply going to add all those up. 3 plus 2 plus 1, I get 6. So that monomial has a degree of 6. Now, when it comes to the degree of a polynomial, it's going to be made up of a bunch of monomials, so I have to find the degree of each piece. The one that has the biggest degree is going to be the degree of the entire, not the monomial, but the polynomial. So here's an example. 6x cubed plus 5x plus 3, that's one of the polynomials I gave you earlier. I look at each piece. 6x cubed has a degree of 3. 5x has a degree of 1. 3 has no variables, so that has a degree of 0. And I look at each of those degrees. Obviously 3 is bigger than 1 and 0, so this whole polynomial has a degree of 3. What is not a polynomial? If you see any of the following, then the expression is not considered a polynomial, which means you do not have to find the type of polynomial and you do not have to find the degree. If you see negative exponents, it is not a polynomial. You don't need to worry about it. We've learned in our previous lessons that if I had a negative exponent, I can cross the line, change the sign, and I could technically bring that negative exponent down to the bottom, which means I would have a variable in the denominator. So if you see a variable in the denominator, it is also not a polynomial. If you see radical signs, again, not a polynomial. Do not have to worry about naming the type of polynomial or the degree. We've also learned in previous lessons that if we had a radical, we could turn it into a rational exponent. The square root of x is the same thing as saying x to the 1/2 power. So if you see rational exponents, again, it is not a polynomial. One thing that we like to do as mathematicians, we like to put things in order. That's what standard form of a polynomial is. When I ask you to put a polynomial into standard form, I am simply asking you to put the terms in order from the greatest degree all the way down to the least degree. So for example here, 3x squared plus 4x to the 5th minus 7x. My exponents, or my degrees, are not in order from the greatest down to the least. So I look at each one separately. 3x squared has a degree of 2. 4x to the 5th has a degree of 5. And minus 7x has a degree of 1. Since the 4x to the 5th has the largest degree, I am going to switch that with the 3x squared to put them in order, so the standard form of this polynomial is 4x to the 5th plus 3x squared minus 7x. After I put it in standard form, you're going to have to look for a new term called the leading coefficient. The leading coefficient is just the coefficient in front of the variable with the largest exponent, or the largest degree. So 4 is the leading coefficient. So again, the leading coefficient, the number in front of the variable with the largest degree. Let's write another one in the standard form. So I look at each piece here, 5y minus 9 minus 2y to the 4th minus 6y to the 3rd, and I'm going to find each piece degree, each term's degree. 5y degree is a 1. Minus 9 has no variable, so its degree is a 0. Minus 2y to the 4th, I have a degree of 4. And last one, minus 6y to the 3rd, degree of 3. I look at each of my degree and I find the largest one. The largest degree is a 4. So I'm going to take that one and I'm going to write its term first, minus 2y to the 4th. The next largest degree, 3. I am going to take the negative 6y to the 3rd and write it after the minus 2y to the 4th. The next largest degree I have is a 1, so I'm going to put plus 5y. And the last piece that I have, the negative 9, which has a degree of 0, so that's going to go last. So the standard form of this polynomial is minus 2y to the 4th, minus 6y to the 3rd, plus 5y, minus 9. Now that I have it in standard form, the leading coefficient will be the first term, or the number in front of my variable with the largest exponent. So the leading coefficient is negative 2. One thing that we would like to do with these polynomials is add and subtract them like we would with numbers. The way that we describe adding and subtracting polynomials is combining like terms. Now, what are like terms? Like terms are terms that have the same variable, and those variables must have the same exponents. So I'm going to add the polynomial 2x squared plus 5x minus 7 with the polynomial 3 minus 4x squared plus 6x. Now, if I look at my largest exponents, my x squareds, you notice that I have 2 of them, so I'm going to combine my reds together. I have 5x and 6x. Those x's have the same variables and the same exponents, so I'm going to point them out by both being green. And the constants, the numbers without the variables, are considered like terms. I look at each of those pieces and I will add them together. So I'm going to put the reds together. I'm going to put the greens together. And lastly, the blues. And I combine from there. 2x squared take away 4x squared will give us negative 2x squared. 5x plus 6x is positive 11x. And negative 7 plus 3 is negative 4. So that's combining like terms and adding polynomials together. Now, what about subtracting? The one thing you have to be careful with in subtracting is that you must distribute the negative sign through the second parenthesis. So that negative sign has to get distributed to the 4x, the minus 5, and the plus 3x squared. It's a lot like your keep, change, change. I'm going to keep the signs in my first parenthesis, change the middle sign, and then change the sign of all of the signs inside of the second parenthesis. So the 4x is going to change into a minus 4x. The minus 5 will change to a plus 5. And the plus 3x squared will change to a minus 3x squared. Then I can look and see, where are my like terms at? I have x squareds that are like, I have x's that are like, and I have constants that are like. I will group them up, and then finally add my numbers up. 2x squared plus 3x squared is 5x squared. Negative 2x minus 4x gives us negative 6x. And 3 plus 5 gives us plus 8. So there's subtracting like terms. The biggest difference between adding and subtracting is that in subtraction, again, you have to distribute your negative sign. Applications of adding and subtracting polynomials. The equations p equals 7m plus 137 and c equals 4m plus 78 represents the number of smartphones p and gaming consoles c sold in m months at an electronics store. Writing the equation for the total monthly sales t of phones and gaming consoles, then predict the number of phone and gaming systems sold in 10 months. To write an equation that represents the total sales t, add the equations to represent the number of smartphones p and gaming consoles c. So what this particular problem is asking us is to find the total t equal to p plus c, or in other words, phones plus gaming consoles. If you look at the equations, the red one, p equals 7m plus 137. The blue one, c equals 4m plus 78. I am going to substitute those equations in for p and c. So the equation is going to turn into what I have here. 7m plus 137 plus 4m plus 78. Now, our goal from here is to combine our like terms. So I have m's in red. I have m's that are in blue. If I take 7m plus 4 more m's, I will have 11m. If I take 137 plus 78, that gives me 215. So this is the equation that represents the total sales. Now, later on in that question, it asks us, what's the sales going to be after 10 months? 10 goes in for the m, since m stands for months, and I use my order of operations to simplify, which will give us 325. So the total sales in 10 months for phones and gaming consoles will be $325. And that right there is adding and subtracting polynomials.